Hello, welcome to the video demo for Intro to Circuits Lab. My name is Amna Muhammad, and today in this video Khaled Alomari and I will be introducing different lab instruments and theory that might be useful for you as engineering students, most specifically circuit students. Circuit 1 to be more specific. In this video we aim to bridge the gap between what you have learned throughout your online courses and how it may play out through practical labs. The way this demo works is that I'll be describing the theory in animation, and Khaled will be showing you how it works or how these instruments work in the lab and how you can operate these lab instruments. So without further ado, let us start. There are 4 experiments in this demo. Make sure to check our description box for the PDF file of the lab manual and go through it as we are explaining the experiments. Many components are labeled or color-coded to identify their value and function. One of these components are the resistors. Resistors use colored bands to quickly identify a resistor's resistive value and its percentage of tolerance. As seen from the table shown in the slide, each color or colored band represents a value. In this example, there are 4 colored bands. The first 2 bands, shown by the color brown and black, represent the value. The third band, however, represents another quantity called the multiplier. And the last colored band, the golden colored band, represents the tolerance. The multiplier represents the power of 10 you need to multiply the first 2 resistor digits by that were represented by the first 2 colored bands. For the illustrated example, the colored band is red, meaning 100 ohms. Therefore, we would need to multiply 10 by 100, and that would give us 1,000 ohms. As for the tolerance, it represents the percentage of error in the resistance of the resistor, or how much more or less you can expect a resistor's actual measured resistance to be from its stated resistance. A multimeter is an instrument designed to measure electric current, voltage, and usually resistance. It can be used as an ohmmeter, an ammeter, and a voltmeter. Let us take a look at how we can use multimeters as ohmmeters. An ohmmeter is a device that measures resistance. And now Khaled will demonstrate how we can use multimeters as a means of measuring resistance.
Welcome to the lab circuit. We will start now the first experiment, which we measure the value of the resistor using the multimeter, and how to connect the multimeter to measure the resistance. First of all, you need to power on, then you connect, as you see here. If you want to measure the volt or the resistance, you need to connect the positive wire to this plug, and always connect the negative wire to the common plug. And if you want to measure the current, you need to connect the positive in this plug. After that, you need to choose the proper function you want. For example, if you want to measure the DC voltage or the AC voltage, this sample is mean AC and this DC. In our case, we want to measure the resistance, so we choose this one. After that, you need to choose the range, and to choose the proper range, first of all, if you get, for example, as you see 1, that means you need to choose bigger range. Go to next one, you will find that it's 0.98, and here you will find the unit, kilo ohm, and our resistor is actually 1 kilo ohm. As you see in the previous explaining how to calculate the resistance using color code. And it's not exactly 1 k ohm, because there is a tolerance.
Multimeters can be used as voltmeters and ammeters. A voltmeter can measure voltage when connected in parallel, and an ammeter is a device that measures current when connected in series. Now Khaled will demonstrate how you can use a multimeter as both a voltmeter and an ammeter. This is a breadboard. A breadboard is a board used for prototyping with electronics and testing circuit designs, and it will be the tool that you use to connect components in a circuit. As seen from the image, we can divide the breadboard into multiple columns. Two outer columns specifically for VCC and ground, and two inner columns for connecting components. The two outer columns are bounded by two lines, one that is blue and the other that is red. The one closer to the red represents VCC, and the column closer to the blue represents ground. The whole column for ground can be considered as a node. Similarly, for VCC, the whole column can be considered as a node. However, this is not how the rest of the breadboard is divided. As for the inner part of the breadboard, each column is divided into multiple rows of nodes, and each node has 5 junctions in it. Don't worry if you don't understand right away. Khaled will now demonstrate what I have taught you so far through the second experiment.
Welcome to the next experiment. As you see, we always use the black wire to indicate the ground and the red wire to indicate the positive terminal. And we want in this experiment to measure the current and the voltage across the resistor. For first multimeter, we connected as a meter. And as you see, always we connect the black wire to the common as ground. And as we want the multimeter work as a meter, we connect the positive terminal in this plug. And after that, we choose the DC ampere function to measure the ampere. And for the range, we try till we reach the proper range. For the next multimeter, we connect it as voltmeter. And as I explained in the first experiment, we plug the positive terminal in this plug. And always, as I said, the black one for the common, which is a ground. And next, we choose the proper function, which we want to measure the DC voltage. We choose this one. And we choose the proper range, as I explained in the first experiment. And this is the power supply, which we get the power from it, and simply from here we just put the voltage we want. And in this experiment we want the 10 volt. And from this two plug we take the output. As you see, output. As I said before, the red is for positive terminal and the black for negative terminal. Now the connection, we connect the ammeter as series with the resistor to measure the current, and voltmeter as parallel to measure the volt across the resistor. First of all, this is the node A, which connects the positive, as you see in the diagram. They connect the positive terminal of the ammeter with the positive with the power supply. And for node B, we connect the negative of the ammeter with the one-off end of the resistor, and with the positive with the voltmeter. And for last node, which is node C, we connect the ground common of the voltmeter with the ground of power supply and with the other end of the resistor. For the result, as you see here, the current is 10 milliampere. As we expect, depending on, according to the Ohm's law, should be the current equal voltage divided by resistor, and the voltage is 10 from the power supply, and the resistor is 1K, so we will get 10 milliampere. And for the voltmeter, as you see here, since the resistor connect parallel with the power supply, so the voltage will be the power supply value, which is 10 volt. It's not exactly 10 volt since there is some tolerance from error device. And now we will start the third experiment. The first part is the series connection. As you see in the schematic, we have 4 nodes. The first node is the A node, which we connect the positive of the ohmmeter to the one of terminal of resistor. And the B node, which this one, which we connect the same end of 2 resistor in the same node. And the same thing for the other resistor, the other 2 resistor, and we call it node C. And for last node, which is node D, we connect the negative of the ohmmeter. And now we want to measure the total resistance of the series connection. And for each resistor, the value of each resistor is 3K ohm. So we expect the total will be 9K ohm. And to see the result here in the ohmmeter, the result is 9.013K ohm. Of course, there is some tolerance. The second part of the third experiment is the parallel connection. As you see in the schematic, there are 2 nodes, A and B. For node A, we connect the end of each resistor with the positive of the ohmmeter. And for node B, we connect the negative of the ohmmeter with the other end of each resistor. And each resistor, the value of each resistor is 3K ohm. So from the formula, the result will be 1K ohm. As you see here in the ohmmeter, the result is 1K ohm.
Function generators are electronic test equipments or software used to generate different types of electrical waveforms, whether it's a sinusoidal waveform, a sawtooth, or even a square wave. And oscilloscopes are used to display voltage signals as waveforms. Before we start with our last experiment, there are multiple characteristics of an AC waveform that we must talk about. The first being the period. The period is the length of time in seconds that a waveform takes to repeat itself from start to finish. This can be also called the periodic time. Frequency. Frequency is the number of times the waveform repeats itself, and it is 1 over the period, 1 over the time. The unit for frequency is hertz. The third characteristic is amplitude. It is the magnitude or intensity of the signal waveform measured in volts or amps. There is an important value for you to understand, which is the RMS. The RMS, or the root mean square, represents the DC value of an AC signal, as you have seen from your course in Circuit 1.
Now we will start the last experiment. First of all, I will explain the function generator. And from its name, it's obvious it's used to generate a different type of waves, such as square and sine wave, also with different frequency and amplitude. First of all, this button used to change the frequency. If I click on it, as you can see, I can change it, the landscape line from here. Then I'll change the number from here, if I increase it or decrease it. For our experiment, we want a 50 hertz, so I change it to 50 hertz. When I change for the value I want, I click in the menu. Okay, then I change the level. Okay, in the menu first. Then for the level, I change the amplitude of the wave. Here it's 1, and I want it 10, so I don't need to change one by one from here. 1, 2, 3, no, I can't change it from this button. If I put here, it will shift the point. So as you can see, it's 10, it's decrease, then it's increase now to 10 volt. Then when I do the change, press menu again. For the next button, it's wave. When I click on it, I choose the wave I want, which is sine wave. When I finish, again I click on menu. If you see the light off, that means there is no output, so I need to make the light on. How? I click on menu, then I choose output by click on this button, then I choose signal by click on this or this button, then it's off, as you see here. Then I just change it to on. The light is on now. Again, click now on menu. Then again in menu 3 times, and this is the main screen. And now we change everything we want.
Remember that frequency is the reciprocal of time. So if we'd like to find the time, if we have the frequency, we can take 1 over the frequency to find the time. As here in this experiment, the frequency is 50 hertz, we can find out the time of the signal, or the period of the signal, which is 1 over 50, which will give us 20 milliseconds.
Now I will explain the oscilloscope device, which is a device that you can see the result of AC signal in the display. First of all, you turn in the oscilloscope. Then, as you can see, there are 2 channels. You can use 2 channels by press this button. But if you want to choose one of them, if you don't click this one, you will choose the first channel. If you click the button, you will choose this channel, the channel 2. Now we have 2 axes, Y and X axis. To control the Y position, you control it by this one, and to control the X position, you control it by this one. And for the voltage, the voltage division for each, that means for each square, how many volt will present. For example, here we put 10 volt, so that means this square, the volt one, this square will represent 10 volt. And for X axis, which represent the time, it's same for the division. You can choose millisecond or microsecond. And also you can choose the value, for example 5 milliseconds. So each square in the X axis will represent 5 seconds. For example, if I change it to 10, it will be different, of course. It depends on the frequency and the period of the signal.
If we chose the division to be 20 milliseconds, then each square in the x-axis will represent 20 milliseconds. It is clear that the function generator, the resistor, the voltmeter, and oscilloscope are all connected in parallel. Let us start with the first node, node A, which is connected to all the positive terminals of each device and the resistor. Starting with the function generator, It is connected to one end of the resistor and the positive terminal of the voltmeter, as well as the positive terminal of the oscilloscope.
As you see the connection, the one of end of resistor, we connect all positive terminal of all devices we use.
As for node B, which is connected to ground, it is connected from the negative terminal of the function generator to the other end of the resistor, to the negative end of the voltmeter and the negative end of the oscilloscope.
And the other terminal, we connect the negative terminal.
The aim of this experiment is to visualize the output of a function generator. As you can see at the beginning of the experiment, we specified a sine wave and its frequency. Later on, we visualized the output on the resistor on an oscilloscope, and we found that it was a sine wave with the same frequency specified at the beginning. And from that, we conclude this last experiment and the video demo of Intro to Circuits lab. Thank you for watching this video, and we hope that this brief demo helped you in a way understand how these instruments that we take in our circuit courses look like and how they can function and how we can use them in different experiments.